Hello, good day to the audience, whoever is listening to this. This is our second project uh, with the same team. This time the project is AI-driven stress detection. Team leader is Sridhar. He will speak after a while. And I am Santanu. So I will give the first few slides I will explain. We have selected the stress level data fitting and prediction. The data source is from kaggle.com. From there, we collected the data or downloaded the data. So basically, our knowledge is based on on artificial intelligence. That is a very good, nice book, I should say. And we started with, after getting the data, we started with data cleaning and preparation. So what we do, there are several methods for, say, NAN or this thing to eliminate and things like that. But fortunately, in our data, out of total 3,000 data lines basically, so we didn't find any data, missed out data. So if you see in this screen, so all the data are telling 3,000 nominal. This is the second screen, and this is the third screen. So there are 19 features with 3,000 data each. So there was no missing data. So we didn't have to do any data cleaning or any removal of any line or any substitution. So when we plotted the feature correlation matrix, so we found that the correlation is very, very low. So everywhere it is hardly exceeding 0.05. All are lower than that. Maximum I see 0.034 like that. So which means that the features are very much independent to each other, not correlated. So one way it is good. So that is what our inference is, that there is no need for dimensionality reduction. Now, if we see the data distribution, then we see that all the data when plotted, all the features when plotted, then it looks a very flat structure for all the data for some reason. So this is a quite surprising finding from our side. So now, Peter will explain you the rest of it. Thank you for listening.
Hi, I'm Sridhar Surapaneni. So I am part of Group 14 along with the Santanu. So till now, Santanu has explained the introduction and how we prepared the data. So now coming to the models which we have used. So we have used three types of machine learning algorithm and deep learning techniques. So in machine learning algorithm, so we used for classification, logistic regression, and random forest. So why we chose logistic regression is because so we have binary classification columns. So that is why we chose logistic regression, as well as for nonlinear relationships and future importance. So we chose random forest. And for the regression, so for predicting the continuous PSS scores, uh, that is the stress score for having a prediction. So we chose linear regression, and we chose deep learning techniques to because we have time series data as well. So that is why we chose LSTM technique. So based on these techniques, so we have set uh, the priorities. So so 33% of the quantile, so we took it as low stress, and till 66 we took, from 33 to 66 we took it as quantile as a medium, and rest of the data we took it as high. So once we did the training of these models and plotted this confusion matrix, so we saw that in logical regression we see that 109 of the data points are focused on medium stress level, as well as, so when we when the actual is when the actual is high, so we see again 120 as the medium stress, which is predicted through logic regression, and the same with random forest. Also with LSTM, so we have seen a different data type where we are able to see that no, so the high the actuals prediction are lower, but the LSTM has predicted high stress with the data which we used. And coming to the results, so based on the training, so we are able to find out four parameters. So we considered four performance metrics for our model. So one is accuracy, one is precision, and one is recall, one is F1 score, and we have also have mean squared error. So accuracy gives us the proportion of correct predictions out of these total predictions, and precision will give us the true positives among all the predicted positives, and recall gives the information of these positive identified out of the actual positives, and is very critical for reducing the false negatives. And for F1 score, so we're able to find out the harmonic mean of precision and recall, so which is like a balance between the precision and recall. So as we can see here in the slide, so the numbers are, so all the accuracy for the three models are very similar and very close to each other. So here we have 0.36, 0.35, and 0. So there is a negligible difference between the accuracy. And in precision, so we find the deep learning model doesn't, with the time series data, doesn't catch up with the logic regression and random forest. And the remaining recall also, all the models perform the same. And with F1, so again, time series data was much lower than logic regression and random forest. So this is a plot between the model accuracy. So as we discussed earlier, so there is not much significant difference. So all the models perform the same. So the conclusion of the work which you have done is, so we took the stress data of 100 participants across 30 days, and the data was collected is 3000 columns. And when we had different columns like sleep behavior, screen time, and all this, so we're unable to significantly find a pattern through these models which can predict the stress level. So what we understood from this is, so there is no significant factor which is the study which we have done, so there is no significant factor which is contributing to the stress. That is because the data, the models which we use, the data set which we used is also limited data set, and the accuracy is also very low because of the data which we used, the available data which we used. And there are some challenges, like, so it requires more multimodal data such as heart rate, cortisol levels, and other health data also to predict, to get an actual prediction, to successfully predict the stress level based on the parameters. Yeah, this is about our AI project work for this course. Thanks, everyone.
Sridhar,
Once